my amazing Algebra I students. This is Mrs. A, and I love math. Today we're doing Lesson 8 in our Orange Book, and we are studying about area. So we're going to have area of rectangles, area of squares, triangles, circles, and even some other things. So this lesson may take us a little bit of time, but it's a fun one. Okay, so here we're talking about what is a square unit. And a square unit is a square, but the square unit is made up of a square that is 1 unit on each side. So the square unit could be square centimeters, or it could be square inches, or it could be square feet, or even square miles, depending on what the units are. But the square unit is always square, and it always has one of the units on each side. So we use the square unit to help us to measure area. And area is the amount of space that is covered in a figure. So here we have a rectangle, and the rectangle is 4 units long and 2 units wide. And if we were to section this rectangle off into its 4 units of length and its 2 units of width, we would have 1, 2, 3, 4, 5, 6, 7, 8 boxes, and each one of those square boxes is 1 unit by 1 unit. So they're each square units. So altogether I have 8 square units. So the area of this figure is 8 square units. Well, instead of counting up all the boxes, wouldn't it be easy to just multiply? Length times width is 4 times 2, which would give me 8 square units. So that's where we get our new formula here. The area of a rectangle is length times width, which you will see in your book, all written out for you in one of the little formula boxes on page 37. Right here, I have a square, and the square has 3 units by 3 units, and if I count each little box here, I have 9 square units. But the fast way to do it would be to multiply 3 times 3, or side times side would give me the number of units that I have. So that gives us our next formula, which is area of a square is side times side, or side squared. And the area is always in square units. So suppose that our square was in feet. So we might have a square that was 2 feet by 2 feet. The answer would be in square feet. Here we're doing example 8.1, and they've given us a figure. Now remember, Mrs. A is not very good at drawing. So these are all square, which means they're right angles, each one of those. And they've given us the measures of each side. So we can conclude that it is boxy like a square. Now we've got all of our lengths given to us, but in order to find the area, we're not looking for the perimeter. We could do this 2 ways. We could cut it right there and find the area of this rectangle and then the area of this rectangle and add them together. So let's do that. So we have 3 times 2 is 6 square units. And then down here we have 6 times 2, which is 12 square units. So when I add those together, I get 18 square units. So now let's divide it the other way. Down here, and we'll take that off, and we'll erase this one and this one. But hopefully we'll still get the 18 square units, but we're doing the math a different way. So here, this one goes all the way down 5 steps, times 2, 5 times 2 is 10. And then 4 times 2 is 8. And 10 plus 8 is still 18. So we did it 2 different ways and got the same answer. This figure, we have a shaded area and then an empty area in the middle. And we're talking about how much area is the shaded area. So this one is going to be a subtraction problem. I have a big rectangle that is 8 by 10 units, and then I've got a smaller rectangle that is 6 by 2 units. Wouldn't it be reasonable if I want the shaded area to find the area of the big triangle and take away the area of the little triangle? So let's write a little formula for this type of problem. Area of the big triangle minus area of the little triangle is going to give us the area of the shade. So the area of the big triangle, 8 times 10 is 80 square units. And then 6 times 2 is 12 square units. And now we're going to subtract the 2 to find the area that is shaded all around that rectangle. And we're going to have to borrow 10, take away 2 is 8, 7, take away 1 is 68 is the area. So 68 square units. That's pretty cool, isn't it? Now this is a very cool and very useful and needful section. Area of a triangle. So I'm going to show you a way that you can always remember the formula of a triangle. So here we have a triangle. This triangle is a right triangle. Since it's a right triangle, the base is the bottom and the height is the straight up leg there. So it is a right triangle. Guess what would happen if we were to extend this triangle and come straight across? Wouldn't we have a rectangle that was exactly twice the size of the triangle? Okay, so basically I'm just extending a parallel line here that's parallel to this one, and then a vertical line here that's parallel to this one, and I form a rectangle. Well, the area of a rectangle is the length times the width, which in this case would be the base times the height. But our triangle that we're looking at is half of that, because this rectangle is double the triangle that we started with. Can you see that? That if I just took that triangle and flipped it over, it would fill up the other part of that rectangle. So that is an illustration that the area of a triangle is 1/2 the area of the rectangle that would enclose it, which is base times height. Okay, so let's look at this one. Does it work with this one? So if I make a vertical line there and I come and I enclose my entire rectangle, my entire triangle in a rectangle exactly enclosed, then wouldn't this side of the triangle be exactly half of this side of the rectangle, and wouldn't this side of the triangle be exactly half of this side of the rectangle? So the area of the triangle would be exactly half of the rectangle that enclosed it. Well, the area of the big rectangle is base times height, so the area of the triangle is half of that. Now it's a little bit harder to visualize this kind of rectangle, so I'm not going to try to show that to you, but it follows the same rule. But this one does not have a height that we can see. Like this one, we could draw a vertical height up from the base, and here we could see one because it was drawn in the original triangle. Here we do a straight drop down from the tip of the triangle, and the base is going to be what we see here on the bottom, but then we just kind of do a dot, dot, dot and extend the base, and the height comes down to that point. So the base is only here, but we extend the base so we know how far to bring down our height. And again, our area of that triangle will be 1/2 base times height, or base times height divided by 2. They both work. So before I erase that board, I wanted to give you a really good look at it, because those are the 3 types of triangles that we'll be playing with. And the area of all 3 is 1/2 base times height, or base times height divided by 2. This is example 8.3. Notice that we have drawn 3 triangles, one right, one that has a height that goes right through the middle, and then one that has the height. This is an obtuse angle, and so the height is outside of the triangle. But notice that in each one, the base is 4 and the height is 3. So even though they're all different shapes, they all have an area that is 1/2 base times height. 1/2 of 12 is 6. So they each have an area of 6 square units, even though they're all very different shapes. Example 8.4, they gave us a triangle that looks very difficult, but when we're working with triangles, we do not have to leave them in the orientation in which we see them. Right here, this one is laying on a base of 10, but if we use this one to be our base, then we would have to find a height that was coming straight down, and that would be too difficult. However, if we rotate the triangle around, we can either let 6 be the base or 8 be the base. The other one would be the height. So let's use 1/2 base times height is 1/2, and it doesn't matter which one we call the base. So let's call our 6 the base, and then right to it is the 8. 6 times 8 is 48, and 1/2 of 48 is 24 square units. Okay, now on that one, they actually gave us that everything was in feet, so our square units would be square feet. We always have to watch our problem to find out what our units are. This problem is a fun one. Anytime we have a combination figure like this, we can easily break it up into 2 figures. So why don't we chop off the triangle, and if this is 6 and this is 4, then this piece in here is 6, and we have a rectangle. If 6 is taken from 10, then this piece over here is a 4 to make up the 10 altogether. If the height over here was 4, then the height over here is also 4. And in the figure, it did give us that these were right angles. Okay, I just didn't draw them in. And now our rectangle is 6 times 4, length times width is 24 square units. And then we have our 4 times 4 is 16, but the area of the triangle is only half of that, so the area of the triangle will be 8 square units. 24 plus 8 will be 32 square units. Okay, so now before I put units down, I'm going to go over there and say, do they tell me? They say dimensions are in yards. So I will take out units and put yards, because they did specify that we were in yards. Now we're moving on into area of a circle. The area of a circle has a formula, pi r squared. And r is the radius, remember, of a circle. We talked about perimeter or distance around, which is called the circumference of a circle. And here we have the radius is halfway through the diameter of a circle. And then in example 8.6, it says, suppose you have a circle whose radius is 3 centimeters. Find the area of the circle. So So we go to the area formula, and area is pi r squared. And then we plug in, instead of r, we use 3, so pi times 3 squared, which is 9 pi. Now this is the exact answer, but very often we would not leave it in the exact answer. The exact answer is 9 pi square, and since that one was in centimeters, 9 pi square centimeters. However, very often, just like when we were dealing with circumference, we will use an approximate. So instead of 9 pi, we would use 9 times 3.14. 3.14 times 9 is 28.26. So 28.26 centimeters squared. So 28 and 26 hundredths centimeters squared would be the approximate answer. One is very interesting. Now we're given an area of a circle is 25 square meters, and we are to find the radius of the circle. They did not give us that. So here, area is pi r squared, and we're trying to find the radius. What we do know is that the area is equal to 25. So what can we do to find the radius? Well, the first thing we're going to do is divide both the right-hand side and the left-hand side by pi. So now, when the pi's go away, we can cancel. We end up with r squared is 25 divided by pi. So r squared is, now let's do our division, 25 divided by 3.14. But remember, when we divide by a decimal, we're going to move this 2 places over. And our understood decimal here is going to move over 2 places, and we fill in with our zeros. So 314 into 250 doesn't go at all. So we're going to use our 3 into our 25 to make a guess. Okay, so 3 into 25 would go 8 times, because 3 times 8 is 24. Since our 1 is so small, why don't we try the 8? So I'm going to try 8 over here. And 8 times 4 is 32. And 8 times 1 is 8, plus 3 is 11. And 8 times 3 is 24, plus 1 is 25, and guess what happened? We went over. So 8 is not going to work. We're going to have to put a 7 here. We guessed wrong, so we're going to go back and undo all of that. 7 times 4 is 28. Carry our 2. 7 times 1 is 7, plus 2 is 9. 7 times 3 is 21. And when I subtract, I'm going to have to borrow. 4, 10, borrow, 9, 10. 10 minus 8 is 2. 9 minus 9 is 0. 4 minus 1 is 3. But the 302 is less than the 314. So we would have a remainder of 302, but we're going to go ahead and turn that into a decimal. Okay, as we move out through the problem, this one is in your book. I've run out of room to divide, but we wind up with, when we carry it out 2 more places, we wind up with 7.96. Okay, so we end up with r squared is 7.96, and the problem's in your book. But now, how do we get to r if we know what r squared is? Okay, well, we know that r must be somewhere in between 2 and 3, because we know 3 squared is 9, and this is almost 8. So we're going to have to go to our calculator and use our square root function, and we're going to find on our calculator that our r is 2.82. So 2.82 centimeters. No, meters. Excuse me. Units are in meters on this one. Meters is our answer. And we did that on a calculator. You don't have to do that any other way. You're allowed to use a calculator to find a square root. Okay? And that is the problem.